panel session at the TCT Show. And I just want to say that I'm so excited to be part of this, not just because it's a great panel of speakers, but because, yes, it's a panel of women, but it is a panel of speakers that are all really great at their jobs, and they're here because they know what they're talking about and deserve a platform to talk about these things.
So I'm happy to have today on stage Nicola Jones, marketing manager at LPW. Then you have Sophie Jones at Additive Scientific, so she's a general manager at Additive Scientific. Have Dana McCallum, head of production partnerships at Carbon, and we have Martine van der Erndt from DSM. So she's the European sales director for DSM. And I think Nicola, you are first.
Good afternoon, everybody. So I'm Nicola Jones. I'm the marketing manager at LPW Technology. Our company is 10 years old this year, so it's a great celebration for us. We predominantly produce, develop and supply metal powders very specifically for the AM industry, the metal 3D printing industry. We don't supply for any other metal powder applications. We are headquartered in the UK, up in the northwest in Runcorn. We've got a big US headquarters in Pittsburgh, network of sales offices across Europe and global resellers across the rest of the world. So we've expanded pretty quickly in 10 years. From our founder, Phil Carroll, starting off on his kitchen table in Cheshire, of which we are immensely proud now, and we have some very exciting plans for the future. So there's a lot of alloy development and the hardware and software processes that go around supporting the applications in this industry. So in terms of my background, I've been in the industry for probably about 18 months. I do have a chemistry background, so a general technical background through biotechnology, general high-tech engineering. I do support very actively the STEM program so that we can encourage our youngsters into technical backgrounds from a young age so that they can be inspired as to how exciting the opportunities are. And just in my spare time, I do a bit of swimming teaching. That's me in a nutshell. Thank you.
Here now, Sophie.
Hello everybody. So I'm Sophie Jones. I'm the General Manager of Additive Scientific. We're a spin out of the University of Nottingham. So the university has one of the world's largest research groups in additive manufacturing. And so what we do is allow companies to have access to that capability and technology. We do things like material development, process development. Basically, if there's something that you want to do that nobody else can quite get their head around, that's where we come in. So we do some really interesting things like pharmaceutical development, we do printing of quantum sensors, which don't ask me to talk about, some really innovative and exciting applications. In terms of who I am, I actually started with the group that head up Additive Scientific way back at Loughborough. So I did my Masters in Engineering there with them, and I fell in love with 3D printing. From there, I went to a company called Economist, which was doing strategy for additive manufacturing. We were subsequently acquired by Stratasys, so I spent some time there before moving to 3T, spending time there before moving to Additive Scientific. You'll hear that the additive manufacturing industry is a bit incestuous and everybody's worked for everybody. I am that person. So I've worked for a few companies now. My job is basically pulling everybody together to deliver the projects and making sure that the professors turn up on time, which is quite satisfying given that they used to teach me.
Hi, I'm Dana McCallum. I'm head of production partners at Carbon, which is headquartered in Redwood City, California. We launched 2 years ago in 2015, and we're creating a technology that's really driving production. So we look at ourselves as a toolless injection molding machine that has software and materials, again, that push into production. I grew up in Ohio in the United States and started off my career in 2010 at Togas, which was an injection molding company. I worked in operations, program management, being the liaison between sales and operations. I had no idea what injection molding was, so I really needed to understand in order to market our technology, which is what my end job was, being the marketing manager. I had to truly understand what injection molding was. So I worked as an operator, as I mentioned, and then also helped on program management, bringing on larger programs from the injection molding side. At the same time I was doing that, the CEO got into the additive space, so that's where I started understanding the 3D printing side and got involved in the industry within AMUG, where I was vice president for a couple of years, and now I'm on deputy VP helping out as we're growing our annual conference. Furthermore, I got involved in women in manufacturing and women in 3D printing with Nora here. And essentially my motto has been, finding your passion, getting involved, surrounding yourself with the best mentors, and networking, which led me to my current role here at Carbon. So as I mentioned, our group, we're considered the Production Partnership Network, which essentially entails design firms, service bureaus, and contract manufacturers that are taking end customers through that product development life cycle and pushing them into production, which is our mission. And these are all of our current production partners. We just announced today Sitem, Fast Radius, Erkschler, and Paragon, who are our production partners in the UK and in Germany.
First of all, thank you so much for the invitation, and it's a great honor to be here today. My name is Martine van den End. I have a background in international business and strategic management. I've been working in the chemical industry for over 10 years now, mainly though in coating resins, composite resins, and fiber reinforcements, and now in additive manufacturing. The European sales director for DSM Somos. DSM is, I don't know if you know it, it's a multinational company listed in the Netherlands. It has about 20,000 people worldwide. It's about an $8 billion company. And Somos is their product brand for stereolithography resins. So in manufacturing, producing, commercialization. And we focus on collaborating and innovating also in the value chain on the end application markets that we find strategic important, and serving our customers and with technical support and information. Today I'm celebrating nearly my 100 days in the 3D printing industry, so I hope today to provide you with an outside-in view. And again, thanks for having me here.
Okay, thank you for those introductions. Okay, so we'll get into the first question, and I'm going to move over here so it looks more like an actual conversation. But we just want to ask, so what was your first experience of 3D printing? We'll start with Martine, because you've already got the microphone, and then we'll work our way down.
No, that's okay. That's okay. Actually, 10 years ago when I started at DSM, I was there for coating resins, presenting my new innovation in a liquid resin. And then another project team was presenting a very cool large engine printed prototype. I was so jealous. It's like, wow, this innovative industry is really booming and this is the future. So that was my first experience.
I guess my first experience with manufacturing or 3D printing was reading about plastic 3D printing in the media. So not through industry at all. So it was more to do with the concept that everybody could have a 3D printer at home, print whatever they wanted and life would be wonderful. Well, I guess it's not quite like that. And aside from that, industrial 3D printing is so much more exciting, so many more opportunities. So my first real experience of that is since joining LPW only 18 months ago.
As I mentioned, I got into 3D printing at university when doing my master's, and I just really enjoyed the lectures. I thought this could be something I could get into as a career. And so one way and another, I ended up to Connolist doing the consultancy. I think I should just emphasize that really was my first experience of the industry with Phil Reeves. If anybody knows Phil Reeves of Stratasys, you'll understand why I have quite a cynical, I suppose, but definitely critical view on the industry. He really taught me how to assess technologies and how to look at where the value really lies in it.
As I mentioned before, when getting hired on at Togas to create their marketing department, as the CEO is developing the service bureau with Additive Technologies, I was also brought on to create their marketing department, so that's where I got to really know the different additive technologies and worked closely with engineers to help provide parts, prototypes for customers on the injection molding side.
we know that 3D printing has been around since the 80s, but we've seen more development since kind of 2010 onwards. Can you each just give a bit of an overview of where you're coming from in terms of additive manufacturing materials, either from personal experience or from your individual companies?
As we all know, we've been asking for more and more materials from the additive perspective and really pushing the boundaries to get into production. So here at Carbon, we're really developing more engineering end-use products using our materials. So when I think one key component of this is working with end customers who are going to produce parts, end parts. So rather than going into injection molding, they're using Carbon's technology, and we're collaborating to understand key requirements for performance. And from there, we're then developing the materials to help them go into production.
So one thing that I hope comes across from this panel session is that we have to start with the applications when we're discussing materials, and that certainly is the case for Added Scientific. We are strongly of the opinion that you need to start with the materials and understanding the characteristics of what you're trying to get to before you even talk about process. Some people come to us and ask, which process should I be using for this technology? We go back to basics and say, which material should you be using? In our case, often the materials are not materials that are available on the market, and so we have to develop ways of formulating them and then printing them. So if you take, say, for example, reactive inkjet printing, what we're doing there is printing two constituents that couldn't be printed in any other way to get a final product that definitely couldn't be printed. And in doing so, we can create brand new materials that you definitely can't print. A good example might be polycaprolactone, for example. Using inkjet printing, we can get some really interesting properties by modifying the formulation. So for us, one of the big things about materials is making sure that the customer understands what it is that they're trying to achieve before we start to look at the process.
So I think for us, the key point is that the quality of the part that you get out is very dependent on the quality of the material that you put in, which is why we spend a lot of time looking at the applications and the specific characterization of the powders that are used in that particular application. But it's not just the application, it's the particular platform that's being used to build the material. So it's very much a case of identifying the correct powder for the correct application for the correct machine. So we have a team of scientists who look very carefully at all aspects of the material to ensure that it is fit for the desired purposes that you're looking to build in.
I think it's very interesting that we're hearing where we are today, where we're focusing on where the end application needs of the customer. They're high demanding industrial needs. So Somos been around there in the 80s, where the first prototyping resins were developed in stereolithography, and yeah, I saw them, they were brittle, they were yellowing, and I think now look at here today, where everyone's focusing on trying to find real solutions for high demanding end applications. So I think the industry has grown very far.
Okay, great. I think the industry can be split into three categories. You've got your materials, your hardware, and your software. As this is a materials panel session, do you ever find that materials can get overlooked amidst the hype about hardware, or have you had a different experience from your personal understanding?
I think what we're hearing here now from all of us is that you have to work together. So you have to have the right machines, the right software, you have to involve the end customer, the service bureaus, you have to involve everyone, the technology development, everyone in the chain to develop a solution for what the customers really need. So I think the answer to the question is as simple as I don't think materials can be overlooked. Neither are the machine technologies or any of those other elements. I think we're one ecosystem, and I think this industry still has a long way to grow and a big growth potential, and I think we really need to focus on working together to make that happen.
And I think just to add to that people are beginning to understand that the materials are important. We're certainly seeing a lot more questions about the materials to be used for particular instruments, and in support of that, also that there are processes around the care of the materials themselves, so the storage, the handling, the transport, the traceability. So certainly we're seeing a lot greater focus on materials rather than just on the machine to build the part.
I would completely agree. We've invested £6 million at the university into a lab purely for material characterization. The issue is, in the past, it's not the most attractive technology or aspect of the technology. You can't take a nice photo of materials. It doesn't, fill up the premium space on your website. But for us, it is the most important bit. So I would definitely agree.
Yes, I agree with what has been said here. I think it's a collaboration of course, material development that cannot be overlooked, but then also creating new hardware and software. So as you look at, the lattice designs or topology, all of the different software that can collaborate with the material side to create better products is definitely necessary.
Yeah, definitely. It's about all of those things communicating well together and kind of pushing each other up. Are there any kind of big challenges that you're seeing in your particular industries at the moment, and is there anything that you think can be done to overcome them right now?
Yeah, so a challenge I think that we see is for end production parts, a lot of the times you have these 2D drawings that have been looked at for several years, and it identifies what that material is that that part needs to be made in. So part that needs to be made in polypropylene, and that's what's engraved in a lot of engineers' heads, and that's the material that needs to be made with for the production part. One challenge I throw out to everyone in the audience here is, what are the key requirements needed for that part? And opening your mind to possibly changing that material, not using that polypropylene, but using a material that behaves like that polypropylene. And for example, there's an industrial tool handle that was injection molded in polypropylene, and we've now produced that in our flexible polyurethane, which behaves like the polypropylene, but it's not exactly the same. And that company has now gone back to their 2D drawing and put Carbon's technology and Carbon's FPU material as an end material to use for that part.
I think that's a really valid point, the whole issue of engineering drawings and what you're used to and what material the customer believes they need. Obviously the properties that you get with AM materials are not the same anyway as traditional materials. So by specifying a material and saying it has to be this, well, you might not even get those properties anyway. So you have to approach it with quite an open mindset. One of the challenges that we're having at Added Scientific and Materials is quite simply getting them. What we're trying to do is print some weird and wonderful materials that haven't been printed before. I think I just paid about 900 quid for about 30 grams of material to come from South Korea, which is eye-watering, but we can't get hold of it otherwise. So when we're looking at new materials like nanoparticulate inks, in particular, conductive inks, things like that, we're really struggling to get hold of those materials. We're starting to see new initiatives coming through, particularly to support nanoparticle development, and I think that'll really benefit us, and it'll give our industry access to better materials. But until we find the applications, I know we're going to keep coming back to that word, but until we find the applications, I think we are going to see the pull-through of these materials being quite slow.
I guess if you're paying that much money for that little powder, the key element that we see is traceability. But it's traceability throughout the AM process. So from taking the material into your production facility in the first place, right through a build and then perhaps reusing the powder, it can quite quickly get very complicated to know which batch of powder you started off, where it is, what it's been built into. So traceability is a key factor, and it's certainly something that we're working in partnership with a number of people on to put in a system that tracks that powder at every stage through its life history. That's to look at all of the testing that gets done along the way, so that at the end of a build you do have a full auditable trail of material that has gone into that part. So certainly for us, traceability is a key factor in terms of the materials.
it's very interesting to be here today and to listen to like coming from a very mature industry. It's interesting to see that the challenges we have today are actually opportunities for growth, because our products in 3D printing are not yet in a mature phase of their development. And I think that is not a challenge. I think it's a great opportunity, because we're here today on a relatively small trade show, but I think this will be massive in 5 to 10 years time, and we've been there, we've been in the foundations of that. And I think we have to think together and work together to see how are we going to make this industry grow and mature, by working together, maybe to start thinking from okay, what does a customer actually want, and to stay in our technology focuses. So instead of from thinking about how is a material going to solve something, it's just know this is the problem a customer has, and how are we going to solve it with the best technology we have. So I think this industry has a great future and a lot of opportunities still to go.
Before I'm jumping to the next question, I would just like to add to Martine's point that you're totally right, and I feel like maybe Dana, you've seen also the same thing coming over, for the last few years, we're seeing more and more partnership between the companies on both software, hardware, material development, and it's actually really exciting to be in this industry today, I believe, for that specific reason that all the companies are starting to actually work really together with the customer in mind as the end goal. So anyway, that's me. Jumping to my next question, I think Sophie and Dana, you actually started to answer it already. But basically, I would like to ask you, how are the new materials opening up a path for more sustainable manufacturing practices and processes, and having an impact more so on terms of efficiency, waste management in other industries, but also maybe in this industry. But I think we're going to start with Dana.
So traditionally, you would develop a product, prototype it on an additive technology, and then once you scale up and go into production, you would outsource a tool, cut a tool, and then put it into injection molding. With Carbon's technology, we're able to use one technology and a set of materials that have been identified to do both the prototyping and the production. So therefore, we're able to increase the development cycle time, the product development cycle time, and furthermore, you can print on demand. You don't need to outsource, and you can do minimum order quantities. So we're really looking at from the sense that you can prototype and produce on the same technology and the same materials.
So sustainability in additive manufacturing is one of my favourite things to talk about. I said I was cynical, and you're about to get it. So when I was with Economist, one of the things we did was develop some software that looked at understanding the embedded carbon in a 3D printed product. And it was really interesting. You will hear lots of claims that 3D printing is environmentally friendly and it's a sustainable technology. By and large, it's a crime to sustainability. The process is the crime. The product is often very environmentally friendly because it's lightweight, because it's exactly what you want, because it consolidates components, because it's built nearer where it's needed. But the process and the materials rarely are. We're talking about potentially heating a bed to temperature for 48 hours and then very slowly melting a spot repeatedly for 48 hours. Or we're talking about disposing of some pretty nasty chemicals. I'm pretty dubious about any claim that 3D printing can be a sustainable process if you just consider the manufacturing process itself. If you look at the wider life cycle, that's when you start to see the benefits. And that's why you have to assess things like aerospace components and any AM component, to be honest, in terms of its whole life cycle. That's why the trade-off between, say, an aerospace component and an automotive component is often different. The life cycle analysis is a completely different thing. You can get the savings from aerospace that you can't necessarily get from automotive. So it's important to look at the full picture.
guess compared to subtractive manufacturing, yes, you are using less material, but there is the caveat as to how we produce that material in the first place. So we do save material versus subtractive. And certainly the classic example is the aerospace, where very much you're looking at lightweighting of components. The less that you have to fly about, the less it costs you to fly the plane, the less it costs you in fuel. So if you're looking for a sustainable answer, then perhaps that's it. But additive manufacturing is not all just about sustainable improvements. It's about the improvements that we can make in the types of parts, types of components that we can make.
The only thing I could add to that is that I think also here 3D printing technologies are still in an early phase of their development. If we see where the environmental footprint, where the automotive sector or the marine sector has come from, and we compare that to today and the steps they will be able to make, I think also for 3D printing, as long as we scale up and we grow this industry together, then at a certain stage we will also produce more efficient and materials with a better footprint and better process.
My next question was actually about the kind of applications you would see really in application of really development into materials in the additive manufacturing space. So I believe it's mostly aerospace who's coming up, but do you have other examples of other kind of applications, anything you are seeing in your industry, in your companies?
I guess the other applications that always catches the eye when it comes to 3D printing are biomedical applications. So the ability to create truly personalized implants, be it cranial implants. I'm told that you can now produce them so well that they will fit a patient so absolutely perfectly that the surgeon can hear them click as they go into place. It's pretty amazing if you think about that. Similarly with dental implants, you can have something which is truly tailored to that individual person. So I'm going to pass this across, and I might just find an example of something that we have to show you.
One of the things I'm really excited about, which if it can be nailed will be kind of game-changing, is printed electronics, and truly 3D printed electronics, where the connections are truly three-dimensional. I keep saying truly, is because mostly we see 2.5 dimensions, where it just kind of goes up. I'm thinking of the three-dimensional stuff. So once we get into that, then we get into the really interesting world of embedded electronics. In order to get there, we have enormous material challenges. It always comes back down to materials. So for me, that's kind of the next big application.
So at Carbon, we've found a lot of different various production applications. However, it's always hard to talk publicly about these production applications. One application that we are proud to talk about are our Additive collaboration in printing the midsoles. So I'm wearing the shoes, and all of our Carbon teammates are also wearing the shoes in the booth if you want to stop by later. But essentially, this application, the midsoles had been talked about for a while, and there's only been a limited release on midsoles with other materials, and Additive is taking us to the next level, and within a few years we'll be producing millions of these midsoles. Right now we're in standard sizes, but you can imagine where you can walk into an Additive store and walk across their floor, and it measures your foot and your strut, and then producing custom midsoles for you. So this will be the largest additive application to date once we ramp up into the millions.
We just got a sample here of a medical implant. It's not a real dog's femur, I promise, but you can just see, and I will pass it around so you can have a look, the implant in the bone. So we can do bone repair, and again, it's built specifically to that particular bone. The other interesting thing to have a look at is the surface finish to the implant there. So it's a finish that will actually encourage the bone growth to graft very carefully onto that part. So I'll pop that around for you to have a look at.
I just think it's amazing to see. We started off with the question, where did we start it in the 80s? It was advanced prototyping, where 3D printing was used, and today we're in medical applications, in shoes, we're everywhere, investment casting, injection molding. So I think that's already a great development. Very impressive to see that like 10 years ago when I started, and to be back there today.
And I can't wait to see where it's going to go. Just starting, I think. And actually, so I think we all agree that we're seeing more and more big industry players coming into this industry. So more so big companies. So you mentioned Adidas in the beginning, the previous question, but we're also seeing more and more chemical giant companies coming in on the material side. So I guess my question is, because well, you are in the industry already from the inside, from the 3D printing industry itself. So how do you see this coming up? You know, big players, so just BASF, Wacker, but also Henkel coming in. I believe, Dana, you actually have something to say about Henkel. Maybe some of you have seen the announcement this morning, but I'm going to let Dana explain it a bit more. But how do you see this coming in? How, you know, those big actors, how do you work with them? Is it challenging? Anything you want to comment on this? And Martine, if you want to start, go ahead.
Yeah, sure. I think, first of all, I said it a couple of times already, but if you're in a today we're in a niche market, yeah, it's still a relatively small industry, and we have all these great end application markets to focus on. And I think in the end, if this is going to be big, and it will be, therefore they're all the BASFs of this world are entering. I think if they wouldn't see that strategic opportunity, then they wouldn't enter. And I think also as an industry, we need these players, and we need these partnerships and collaborations to make it grow and mature. So I think it's yes, they're all entering, and I think it's a great opportunity also together to grow this industry.
I agree, and when we see the bigger company names coming into the industry, it gives it more traction, more people take notice, more investment, more partnership opportunities, which helps to drive innovation even faster. So it's a tremendously exciting time now that the bigger companies are really standing up and taking notice.
Yeah, so as Martine mentioned, you know, collaborating and opening up and working with a lot of different chemical companies are going to take us to the next level. And today, Carbon, we had a press release go out of our partnership with Henkel. Obviously, creating new materials, better materials is always a great thing. In addition, we need to look at the economies of scale. So as Sophie mentioned earlier, current day, a lot of the pricing for materials is way too high to really push into production. Our partnership with Henkel allows us to be able to provide bulk resin and thus reducing the price from $250 per liter down to $150 per liter in our RPU material. And you can imagine us validating more and more materials using their Henkel's mixed meter dispenser and bulk resin to push more resins at lower prices to our end customers. And one thing we like to highlight is this is a collective effort. It's not just, you know, Adidas or just BMW using these end resins. It's everyone, both Adidas, BMW, Fast Radius, Paragon, all of our customers who are using these materials. As we scale up, we can drop those prices, just like injection molding.
Yeah, again, it's really all about those partnerships, really just pushing things forward. This next question, I suppose, could have quite an interesting answer, kind of controversial, I guess, but this is more towards Nicola and Sophie. We're seeing more AM hardware vendors coming in, using more standard manufacturing materials like MIM materials. Do you think this will help increase adoption by, you know, lowering barriers, lowering costs, or do you think will we always need those specialized powders for additive manufacturing?
I guess I'm supposed to say yes, you'll always need them, but there are good alloys out there already. They are well characterized. The mechanical properties are well known for the applications, for the technologies they were developed for. They do have uses in additive manufacturing. We do have to look carefully at the materials to characterize them, to make sure that they're the right size, that they flow. So yes, certainly the existing materials have a place, but we wouldn't want the technology to be limited by currently existing alloys, currently existing metals. So there's always a place for innovation in materials. As new materials come on board, that can generate new applications. Conversely, new applications can demand new materials. So there is a tremendous amount of work being done and to be done in terms of understanding what is required to generate an AM powder that will give you the powders that you require for the application that you are using. So there's a lot of work to be done. So we're not going to throw the old out for the new, but we're going to use the old, take what we've learned from the existing materials and look to develop new materials for new applications into the future.
I think this whole kind of debate about whether we should use existing materials like the metal injection moulding materials or not, or if we should develop our own as kind of LPW do, is an interesting one. As a manufacturing engineer, my gut feeling is that you have to look at the cost of quality. Whilst it may be cheaper at the front end to use ready-to-go materials off the shelf that are used for other applications, if that results in extreme shrinkage or it's not giving you the qualities that you would expect from a true AM powder, then it's unlikely that you're going to see the cost benefits over the production of that part. So gut feeling says I think we should be looking at specialised materials, but I would happily be told otherwise by a metallurgist.
Okay. For the next question, we're going to sort of jump to sort of future looking. We've got new processes coming in all the time. What's next for each of you for AM materials? Is it going to require a whole new class of additive manufacturing materials to keep up with these new processes that continue to come in every single day?
So Carbon is a newer company, and I think we go back to the answers that we've all been saying today of collaborating and working with the end customer and understanding what the true requirements are for materials. Of course, as we develop more materials and put those through validation, that's going to drive adoption into more applications. But we really do need that collaborative effort to do that.
For me, a new class of material would be a true multimaterial. You'll see on the Stratasys stand, they talk about multimaterial, and yes, it is multimaterial kind of, but it's not mixing polymers and metals, for example, or polymers and ceramics. And I think that's what we're going towards. It's maybe 5 or 10 years out, but it's coming. The challenges that presents are quite substantial. How on earth do you recycle something that is made up of plastics and ceramics and metals all in a single component, all bound together? I don't know. And how on earth you do quality control on that as well, it's beyond me. But I think we're going to have to address these problems as an industry.
One thing that we are looking at is the data that we have available on the existing materials and to understand them throughout the process. So it's to look at pooling data from different organisations, different parts of the process. We already can take data from material before it goes into the machine. There's the capability to take data whilst it's in the machine to look at the properties once the part is built. And it's a pooling of all of that information to build up a real big picture of actually how additive manufacturing materials do work in practice. So there is an enormous project there to understand before we start to develop the new materials. So it's an understanding from my perspective that we really need to generate.
I think it's difficult to be the last one here. I think it's all about collaboration, it's about multi-materials, and it's about the big data. So I think the main thing is that we have to go as an industry beyond thinking in liquids, powders, or filaments. I think it would be great in the future that we can look at a problem or a solution for an end customer or an end application need, and independently of the technology, we print it. I think that would be our future.
Believe it or not, we're running out of time now, and I would like to open the floor for questions from the audience.
How does the trade-off between open source and proprietary materials interact with Nicola's focus on traceability?
I guess it depends what you mean by traceability. Proprietary information is always a tricky one, and whenever you set off on a project, there's a whole lot of work for the lawyers to do first. So it is a difficult situation. I guess where there's a will, there's a way. So if people are prepared to help support collecting the data, then I think we can make tremendous leaps forwards. There are always ways to anonymize data if we really want to. And I guess the more data that we can collect, the easier that process is. But it's always a tricky situation, tricky question.
Dana, I think you just answered this for yourself, but each one of you, I'd love to know what you personally are planning, are excited to bring to the industry, either technology or mentorship or whatever it is?
So the company that we're setting up, Added Scientific, I'm the only person without a PhD there, so I'm the thick one. And what I want to do is create a company that can elevate just the brainiest people imaginable and give them somewhere where they can develop really quite wacky and wonderful technologies that just wouldn't have got developed anywhere else. So if I'm to bring something, it's to enable those people to kind of do the most amazing things.
I guess mine is somewhat related to that, because we do have a very good smashing of PhDs in our company, but we also have an awful lot of extremely capable youngsters who've entered the company. They might not necessarily know exactly where they want to go in manufacturing yet, so I want to make sure that they have every opportunity available to them, whether it's through a traditional apprenticeship route or whether it is through sponsoring them through a degree, whether that's a first degree, a PhD, so that they have the opportunity to basically to get to where they want to be and to where their capabilities will take them.
I think in terms of the company, the reason why I joined the Somos team is that I see a huge opportunity for them to break out of the small niche that they also had within DSM. So I'm very happy to and hope to provide a differentiated view there, that we're part of a bigger whole and that we have to grow this industry together by focusing on the right things. Even within DSM, we found many departments actually doing 3D printing without being connected to each other. So it can be very small steps, but I think that's very, very important. It's networking, working together. And on a personal view, it's always been my mission to continue to excite young people for chemistry as a whole. So I think coming from the commodity resins, it was always the chemist left to go to 3D printing, yeah, because that was cool. But in general, I think we need to continue to excite students to join technical studies.
I can't help but wonder, because we are 6 women on stage, and I think that's worth noticing. This is not something we see a lot in this industry, sadly. So I wanted to ask you, as women in this industry, have you ever had challenges, again, from being women in this industry?
It's always a hard question.
I know, that's why I'm keeping for the end.
Every industry has challenges. They may be gender-based, they may not. I think it's how you deal with it, and it's probably where you find yourself in industry, because if you follow your passion, if you follow what you enjoy, what you're good at, you tend to find your place. And I think industries these days are opening their eyes to actually looking for the best talent, irrespective of male, female, whatever. So I think things are changing, which is for the better. I'm pleased to say that certainly at LPW, in our latest intake of apprentices, we have 3 extremely capable young women, and you actually, this is no disrespect to them, you don't notice the fact that they're women, you notice the fact that they are fabulous apprentices. So I think we're making the right moves.
Yeah, I think whether you're a woman or a man, or whether you're born and raised in Shanghai or here in Birmingham or wherever in the world, I think we all bring a unique skill set. And I think it's all about awareness, how to use your strength, and accept the fact that maybe you have some weaknesses, but focus on who you truly are. And then, yeah, I think build from that and make your difference in your industry.
I think the question, have I faced challenges? Give me a drink after this and I'll tell you some horror stories. But quite seriously, it's, yeah, there are challenges. And I think what's been disappointing for me in the kind of the 6 years I've been in the industry is that I haven't really seen the numbers change, if I'm brutally honest. And it's something that I am so enormously glad that Nora and the women in 3D printing team are kind of flagging. It's given me the confidence to speak up this year because I've seen the activities that they've done online, and that's been fantastic. Up until this year, I hadn't brought it up. This year, I've started to, and that is no question about it. That's down to you.
Thank you, Sophie.
I mentor quite a lot of young women, and I do think about it. I do think I'm encouraging you to go into an industry, and I know you're going to face crap, and I'm still going to encourage you to do it, because if we don't encourage them to do it, they're going to face a lot more than if there's fewer of them.
So when I first joined the industry, there were very few women involved, and I think the positive note is that we've increased the amount of women involved in our industry. At Carbon, it's been a main focus of ours, having diversity. And one mission for me is to educate children on manufacturing and why to get involved, and obviously that includes females, and showing that it is a viable career option for them. Just today we had a group of students stop by our booth, and I was talking to each of the female students and saying, you know, how do you want to get involved in 3D printing? And they're already designing products, and that's where it starts. If we don't start educating children at a younger age, then we won't see a shift in having more women involved in our industry.
Totally agree. Thank you.